So, let's start with, let's say that I have y equals 2 square root of x minus 1 plus 3. Okay. I give you this radical yesterday. Give me the transformations. Right 1, up 3, vertical stretch by 2. Give me the domain and range. X was greater than or equal to 1. Y was greater than or equal to 3. And then the sketch of my graph, I would go over 1, up 3, and that would be my graph. Good? All right, so today I want to find the inverse of this. So what do I have to do when I find the inverse? What's the first thing? Flip x and y. And then solve for y. Right? So I would bring this 3 across first. My advice to you, just so that you can keep transformation straight, instead of dividing by 2, I would multiply by 1/2. Square it. Remember on the first day I said, or I reminded you that if you have 2 things that are being multiplied and you square it, you have to square each piece. So if I'm going to square this, I have to square the 1/2 and I have to square the x minus 3. That's where the 1/4 came from. So I have 1/4 x minus 3 quantity squared plus 1. This is my inverse. Right? Here's my question. Domain, range. What's the domain of that function? How about that, Mr. Willie? X is greater than or equal to 3. It is not all reals. Tell me why.
I don't know.
Lucky guess, he says. X is greater than or equal to 3. Why is it not all reals? I can take anything and square it. Yeah.
Is it because y was greater than 3, so it's inverse? So it's actually be greater than 3?
Yes. When I find my inverse, we talked about it the other day, I put a number in, I do something to it, and I get a number out, right? And then when I take the inverse, I take the number that I got out, I put it in, and I get the number that I started with. Here's the problem. I put my numbers in that are bigger than 1. The only numbers that I'm getting out are bigger than 3. So as a result, in my inverse, the only numbers that I can put in are those bigger than 3. Does that make sense?
What's this graph look like?
This well, my range, first of all, would be y greater than or equal to 1 then. And then my graph will be over 3, up 1, both greater. Whoops, sorry, no. Right? So basically, think about this. If I were to give the transformation, oh, actually, I should have done that. Transformation, this goes to the right 3, up 1, vertical compression of 1/4, right? So my vertex of the parabola would be over 3, up 1, and my parabola would look something like this, right? But I have to cut this out because those values less than 3 are not coming out of my original function. Oh, we're actually going to get into that. Okay? What's this point? This point is at 3, 1. What's this point? 1, 3. Y equals -1/2 square root of y plus, or x, sorry. Let's do this. Let's go 1/2 x minus 1 plus 3. We'll throw, and actually I'll make this negative. Yeah. I'll just start throwing all sorts of stuff in. Okay? Now think about this though. Okay? In this original, the stuff that you did the other day, this goes right 1, up 3, yeah, horizontal compression, no, horizontal stretch by 2 and reflect on the y-axis. Up 3, vertical compression and reflect on the x-axis. So I've got all 6 transformations in there, right?
Vertical compression.
Oh, yep, by okay, so with the radical, my domain, x went to the right 1, I reflected it, so less than or equal. My y went up 3, reflection, less than or equal. So if I go to graph this, over 1, up 3, less and less, down and to the left. Good. So now, if I find my inverse, I'm going to combine steps, so see if you agree with this. I moved my 3, and I'm going to multiply by -2, and that's equal to the stuff under my radical. Right? I'm going to square them both. Multiply by -2. One by one. Okay. So this is my inverse. Transformations. Right 3, up 1, vertical stretch of 8, reflect on the x-axis, right? Domain and range. Give me the domain. And my y? Okay. Now, my y would be less than or equal to 1 here anyway, right? Goes up 1, this is going to open it down. So it's going to go 1 on down. Problem is I'm restricting my domain. So I go over 3, up 1. That's where my vertex would be. And then my parabola would open down like this. But I'm restricting it for x values less than or equal to 3. So these over here don't count.
Why is y less than? There's no reflection over y.
It's a reflection over x.
Over x.
The x-axis affects my y values.
Y is x less than.
Because when I put my x's and y's,
The guys did the
so this domain has to be, or I'm sorry, this range has to be this domain.
same. Also, you made something like
Yep.
Is there a way to check to see if your inverse is right?
Yes. Put. So I'm going to try and think of something that would be, let's take, I'm going to take -1. Okay. If I put -1 in here, -1 is -2, times -1/2 is +1, square root is 1. This will give me -1/2, so I would get 2.5 out. Right? If I put 2.5 in here, I should get -1. So 2.5 minus 3 is -1/2. Squared is 1/4. A 1/4 times -8 is -2. Plus 1 is -1. So if you put a number into the original and get something out, take what you got out and put it in and hope that you get the original number out. If you do, your inverse is right. If you don't, you either have a computation mistake or your inverse is wrong. Okay? So, you already touched on this a little bit, but I want you to justify to me why is the inverse of a radical function not a full quadratic?
Because it has a restriction in the domain.
Has a domain restriction. Okay? When I find the inverse, I get, when you find the inverse, you'll get a quadratic function out here. The problem is, because your domain is restricted, your graph and your inverse is not a full quadratic function.
So in your calculator, could you put the inverse of that equation and graph that, or not?
No. Now you can graph both of these. Okay? Now, here's something else I want you to play with. What's this point? 3-1. What's this point? Okay. Now, you already have those. Ooh, that calculus out of the way. Hate to scare anybody off.
It's in the same wall.
Okay.
But it just goes. It's reflected. It's reflected.
I'm going to dump this off the board. So I started with In these two problems, okay, you could give me those points and you looked at the graph. Now, this is the quadratic stuff, and this is, when I talked to Ms. Wagner, I said, this is the thing that I don't like about distributed homework because you can't put it all together. Because I'm not assigning it all at once. Okay, these were problems off your homework, but I just took everything at once. This was my function after I completed the square. Okay, here's my transformations. This was what my quadratic looked like. This was the inverse domain and range, and this is what this looked like. What is this point right here? 3, -9. What is this point right here? What's this point right here? And this one? What do you notice about all of my functions and their inverses? They're what? Flip X and Y. Okay, now let's go back to your days of geometry. When I flip my X's and Y's, what type of symmetry does my graph have? No. Talk to your partner, try and dream something up. Play around. What's that? I'll give you a hint. It's a line.
No, I'm just kidding. It's a line. It's a line.
What do you call that?
I'll put those two on the same graph. It's a little more to scale. If I switch X and Y, what line of symmetry am I looking at? What?
XY.
Not XY. What? Not X times Y. What's my line of symmetry? No. Not X plus Y. No. No. It's not around the axis of symmetry. Well, it will be, but what is my axis of symmetry? In other words, these are symmetric about what?
The slope of 1.
What? Yes, the slope. Y equals X. All of my graphs are symmetric about the line Y equal X.
I tell you, and you looked at me funny.
Okay? Now, the reason, what do I do when I find my inverse? You switch your X's and Y's to find your inverse because inverses are symmetric about the line Y equal X. My Y's become X's and my X's become Y's. When you do that, in geometry, I'm sure that you had, like, take a look at this, see if this looks familiar. Let's say that I reflect on the x-axis. Then a point AB becomes A negative B. Did we do that in geometry? Or if I have AB and I reflect on the y-axis, it becomes negative AB. And you had all of those things, and when you did like a rotation, like a 180 rotation, it's negative A, negative B. Right? You had all of those things. If I reflect about the line y equal x, what happens to my point? It goes to BA. So I reverse my x and y values, make them symmetric about the line y equal x. Function in their inverse. Kind of cool, isn't it? See, the thing that people think is funny is for as much as I rip on geometry, how much geometry I talk about in this class. Okay? Questions? You know, isn't it great? Everything's coming together. We're getting smart. Okay? Now, here's what you have to be careful of. If I give you the quadratic as an original function, what's the domain? All reals. I can put anything in and square it. If I give it to you as an original function, the domain isn't restricted. So it's all reals. The only problem is when you get a quadratic, or a quadratic as the inverse. If you look at this inverse, if I gave you this as the original function, my domain is bigger than 1, my range is bigger than 1/2. If I go backwards, this is still my inverse function, but my domain is greater than or equal to 1/2, and my range is greater than or equal to 1.
The inverse of the inverse.
Well, yeah, but if I gave this to you as the original,
Yeah.
because of this domain and range restriction, I have to restrict the domain in my inverse. But if I give you the quadratic as the original, which is what I did, your domain is all reals for that quadratic piece. Okay? Questions? Okay, so I need you